Next, we'll take a look at rendering the popular TurbulenceFD plugin. As you can see, I have already prepared a setup where the solid angle logo is emitting temperature and density in positive vertical direction. In turn, these channels had been mapped to the smoke and fire shader respectively. What's interesting about rendering this plugin is the fact that the TurbulenceFD container is being interpreted as if it was an R-node volume object. To adjust the sampling quality for the volume, we need to assign a parameter stack to the TFD container. Here we have the familiar step size parameter, which for this example I will take down to 0.01. Even though we still need a material with the volume collector shader assigned, R-node is able to render the TurbulenceFD plugin right out of the box. To change the look and feel of the output, you can either use the parameters in the rendering tab, or simply assign a material with volume collector and play with the shading in the network editor. So let's create a material, apply it to the TFD container, open up the network editor, and connect a volume collector to the beauty port. This, as you can see, will immediately reset the shading to its default state. So let's rebuild the volume collector so that it is one more time able to sample the correct values from the TFD container. Working with Turbulence resembles reading available data channels stored in an open VDB file. With TFD, however, we're given access to cached channels and active shaders from the rendering tab. This means that with the current setup, we should be able to sample temperature and density, plus the active smoke and fire shaders. So let's change the scattering and emission to channel and set the attenuation source to scattering. Scattering will be based on smoke and emission on the fire shader. And there you go, we're back to the initial look. To complete the shading, I will change the attenuation color to blue and increase the intensity of all three channels to a value of 10. In this part, we'll discuss shading our TurbulenceFD simulation by using the volume sampling nodes. I have already set the mapping for the smoke and fire shaders to none, meaning they will not be available for sampling in the network editor. This leaves us with the temperature and density channels. So let's use density for scattering and set the strength multiplier to 100. Change the attenuation source to scattering, increase the intensity to 20, and select extinction from the attenuation mode dropdown. Next, create ramp RGB, change the colors to purple and red, and use that to drive the scattering color. Drag a volume sample float in, read out the density channel, and use the output as mix amount for the ramp RGB node. To fine-tune the distribution of values, I will reduce the bias and gain parameters to 0.35. And that's the smoke all done. Let's do the same procedure for the emission. This time we will read temperature, and increase the intensity to 400. Drag another ramp RGB in and change the colors to red and yellow. Connect the output of ramp RGB to emission color. Create volume sample float and once again reference temperature. Use that to blend the values of the ramp RGB. To cap things off, I will reduce the input max to 0.1, which will give us the final result.